Set sail for the second star to the right and straight on till morning.
Three, two, one.
One of the big challenges of space exploration is propulsion. How do you move around? For most of our missions, we have relied on rocket fuel as our means of propulsion. You burn it and you get a propellant. But it comes with some pretty big drawbacks. For one, it's heavy, so the more rocket fuel you add, the heavier your spacecraft gets, the more rocket fuel you need to escape Earth's gravity, and it becomes this domino effect. For another, it's really expensive. And third, once you run out of it, you're kind of out of luck. So let's say that you are in space and you want to head to a distant destination. If you're using rocket fuel, you can only accelerate until you run out of fuel, and then you have to rely on inertia to take you the rest of the way. But what if you used an alternative means of propulsion, like a solar sail? Now, a solar sail is pretty much what it sounds like. It's a large, flat, reflective surface off of which photons can bounce and transfer momentum. Now, a photon is a packet of light energy, and it is massless. Now, this might seem counterintuitive because if you remember your basic equations from physics, momentum is mass times velocity. So, how can a particle that has no mass have momentum? The answer lies in Einstein's brilliant equation E equals mc squared. The E stands for energy, the m stands for mass, and the c is the constant of the speed of light in a vacuum. This tells us that energy and mass have a direct connection to each other. So if we shuffle that equation around a little bit, we'll see that a photon, which has energy but no mass, has a momentum equal to its energy divided by the speed of light. That means it has very little momentum, but a solar sail is designed to capture billions of photon collisions per second. So all those little pushes add up to something. In fact, a solar sail will continuously accelerate until it can no longer catch photons. So what sort of speeds are we talking about? Well, when you first deploy the solar sail, the spacecraft will not be going particularly fast. At the end of the first day, the spacecraft would be traveling at around 160 kilometers per hour. At the end of the first year, it would be more like 58,000 kilometers per hour. And after 3 years, we're talking 160,000 kilometers per hour. That steady acceleration stays in effect until the solar sail is no longer able to capture those photons. And the best thing is, this isn't hypothetical physics. We have actually tested solar sails. In fact, the most recent effort was from a citizen science organization called the Planetary Society. They launched the LightSail, which had a couple of glitches when it launched, but it did successfully deploy its solar sail. Now, the LightSail wasn't used for propulsion. It was just meant to test the deployment mechanism. But the Planetary Society has another mission in mind for late 2016, which will actually use a solar sail for propulsion. And they've launched a Kickstarter campaign to help get people involved in it, which is pretty awesome. Now, in the future, solar sails might be used for lots of stuff. We might use solar sails to take supplies long distance to destinations like Mars. Maybe we'll use solar sails to help protect us from an incoming asteroid collision. Just attach the solar sail to the asteroid and have it tow it out of the way safely. Or perhaps it will be the propulsion method of choice for interstellar travel when we're ready to go to another solar system. Alright guys, I've got a question for you. What sort of citizen-based science project would you most be interested in getting involved in? I want to hear your thoughts in the comments below. I want to thank Toyota for sponsoring our show and making this possible. If you enjoyed this episode, make sure you hit that like button, subscribe to Forward Thinking to join our think tank, and then set sail for these videos right over here.